Volume formulas. Let's find the volume of a prism. Okay, really basic. If we were dealing with length, width, and height, it would just be length times width times height, okay? But if you're dealing with a situation like this, which you have seen this picture before in the surface areas, if you're dealing with a situation like this, then what you could do is, check this out, check it out, check it out. You can find the volume, you've seen this one before, you've seen the surface area video. You could find the volume of this three-dimensional figure, like how much water would this hold? Well, none, there's holes all in it, but work with me here. If this was somehow, covered, what would the volume of this be? Well, I would find the area of this. I can find the area of that triangle because it's the base. And then I would say, well, I'm going to take this and just make another dimension out of it and multiply by the distance between those bases, which would be the height. So if I wanted to know the volume of this situation here, then I can find the area of this hexagon, this yellow, really bright yellow hexagon, and then I could say, well, how far apart are these two hexagons? And so take that area and multiply by height, and you're going to have area times another dimension, which is going to give you volume. So with that in mind, the most simple way I know to write the volume of a prism is base area times height. And it's really that easy. I'm going to put this one in parentheses as well. So base area times height. And when you look at that, you're like, okay, well, that is pretty basic. I do want to clarify, though, what I'm talking about. And the base area is going to be the area of, well, the base, but again, for the 200,000th time, we're not talking about they don't have to be sitting on their bases. Like the base in this situation could be left, right, front, back, top, bottom, could be any of those. In this case, the base is the triangle. And then the height is going to be the distance between the bases, and I do want to clarify that. So distance between bases, and that has been clarified before. And I use capital B for bases here. And the bases, again, to clarify, there are the two faces that are equal in area and they're parallel to each other. And I want to write that definition down. So bases, and this goes for the surface area as well, but bases are the two faces in this context, in the context of a prism, that are equal in area and parallel to each other. Okay, so if I wanted to find the volume of a pyramid, what would I do? Well, okay, clearly it's not a prism. And the cool thing about it is, and I used to have these like three-dimensional things that would hold water, and I would demonstrate it, but I don't have them, and I would get wet if I tried it, because I did. Got water everywhere. It's the same situation you have here, only it's going to be 1/3 of it, because you're going to have less area, right? Less volume. So it's going to be 1/3. How do you know it's a third? It works. I don't have time to go into it right now. I sound like I'm in a massive hurry. I'm really not. Look, just ask me later. But it's 1/3, base area times height. And again, I want to clarify what the height is. In this case, the height is from the tippy top down to the middle of the base. And we're assuming that it's going to be a right prism, a pyramid. That is the height right there. It looks like some musical notes. That's not what I intended. That's what we're dealing with. It's a right angle. Okay, so that deals with the pyramid and with the prism. Let's move on to the cylinder. All right, if I want to know how much volume a cylinder has, the volume of a cylinder, then we can, well, find the area of the circle at the bottom, and then we can multiply by the height. And you've seen all this before. I didn't put these formulas on the surface area ones, but there they are. And for a cone, it's three-dimensional, and it looks very similar to the cylinder, only it's pointy. And how much does it hold? Well, if the radii were the same and the height is this one, all right, that's going to be height. And just because I feel like clarifying it, this right here is the slant height. I just want to point that out. That would be this guy right here along the side. There we go. That's slant height. Just saying. And then this, of course, is going to be, that's the radius. All right. In this case, it's going to be 1/3 pi r squared h, similar to a pyramid. So, you know, if you have a prism compared to a pyramid, this one's going to be a third. Same. Cylinder compared to a cone, this one's going to be a third. And the sphere is, okay, don't have a way to explain this one without just saying it. It's going to involve a little bit of calculus. Could. There's other ways of explaining it as well. But 4/3 pi r